In this video I present to you Vivian, our technical framework for deploying and operating virtual prototypes in XR. My name is Patrick Harms and I'm from the Nuremberg Institute of Technology. Some years ago, these new XR systems came to the mass market, and we asked ourselves whether we can use this technology to evaluate the usability of technical devices, for example home appliances. And for this we put virtual prototypes of these devices into XR and asked users to interact with them. And any problems that these users had could be indicators for usability issues of these devices. What we found quite challenging was the creation of these virtual prototypes. The reason is that you typically start with some kind of static 3D model that may pop out of a CAD software, for example. But what you need in the end is some kind of interactive 3D model of the technical device, so something that reacts on user input. And even more, you need the interactive 3D model of the technical device to run in different XR setups. For example, directly on a PC, in mobile AR, in VR with a controller-based interaction, or in VR with a hand-based interaction in case you have some hand tracking available. And this is where the Vivian Framework comes into play. Our framework supports a rather fast and efficient transition from static 3D models of technical devices to interactive 3D models of technical devices that can run in different runtime environments, meaning different XR setups. How does the Vivian Framework work? The Vivian Framework consists of a core component. This core component is fed with a static 3D model of the technical device. In addition, users of the framework need to specify which elements of the static model are interactive, basically which element is, for example, a button. Furthermore, you have to specify which element can be used to visualize something, for example, which element is a light or which element is a screen. And finally, you specify what happens when, and for this we utilize state machines. State machines are made up of states, and these states define in which state a certain prototype can be in. For example, it is switched off or it's in some kind of ready state. And for each state you specify what the visualization elements show in this specific state. For example, that a certain light is switched on or what content a certain screen is supposed to show. Furthermore, you specify the transitions between these states, and these transitions are typically reactions on user interactions with these interaction elements. And when you have done all these specifications, then you can deploy and operate these virtual prototypes in different runtime environments which were prepared by the framework. The currently supported runtime environments are a PC runtime environment, which is quite useful for testing and debugging, a mobile AR runtime environment on smartphones, a VR-based runtime environment with a controller-based interaction, and a VR-based runtime environment with a hand-based interaction using a hand tracker. We are already working on further runtime environments, for example, a runtime environment for the Microsoft HoloLens. Let's have a closer look at what can be configured as interaction and visualization elements. The available interaction elements are buttons, sliders, rotatables, touchables, and movables. A button is everything that you can press. A slider is everything that can be moved on a straight line between two extreme points. A rotatable is everything that can be rotated around a certain hinge point, for example a knob, but also a door that opens. A touchable is any kind of surface that users can touch on. And finally you have movables, which can be any kind of virtual object that can be moved freely in space. For example, a virtual coffee cup that you want to put under the outlet of a virtual coffee machine. Let's have a look at the visualization elements. As visualization elements, the framework currently supports lights, screens, and sound. A light is anything that can glow in a certain color. A screen is everything that can show some kind of content, for example, an image or a video. And sound can be any kind of file that is played if the virtual prototype changes into a certain state. The combination of a screen and a touchable basically makes up a touch screen. And finally, you specify the state machines. These consist of states, transitions, and guards. A state specifies which light is switched on in a certain situation or which content is shown on a certain screen. The transitions specify which state is reached in case the user interacts with some kind of interaction element. A further type of transition is a timeout transition. This allows you to specify that a certain state change occurs after a certain time elapsed. And finally, we have the guards. These guards are quite important to specify that from one source state you can reach different destination states, depending on some kind of condition. A typical condition that you want to specify here is that when you have a touch screen, that not every touch on the whole screen shall lead to the same destination state. Instead, it should be that a touch on the top left, for example, leads to another destination state than a touch on the bottom right. And for this, you can utilize guards to specify different regions on these touch surfaces to define different destination states for these regions. To evaluate whether our framework is capable of modeling typical technical devices, we performed a small evaluation study. In this study, we implemented 4 different virtual prototypes, one being a TV, a microwave oven, a toaster, and a car infotainment system. The TV was a rather simple TV. It mainly consisted of a rather large screen to show 3 different videos, and using the remote you were able to switch it on and switch between the different channels. The microwave oven was a bit more complex. It had a light inside of it to visualize that the door is open. You were able to open the door was configured as a rotatable, and you had this coffee cup which was configured as a movable so that you can put it into the microwave oven. The toaster is one usage of a slider. You can use the slider to switch on the toaster. A light was used to show that the resistors inside of the toaster are switched on and glowing. And we also had a rotatable that allowed us to set the duration after which the toaster was supposed to finish the toasting process. Here we also used our timeout transitions to specify these different timeout times. And finally, we had the car infotainment system. This was mainly set up of the radio functionality of the car, but it also allowed to set different settings of the car. Everything is set up using a touch screen, so there we made intensive use of our guards. What we found out is that basically we were able to configure all these prototypes. We were able to run these prototypes in all the different variants of XR that we wanted to support. So on a PC, which is shown on the top left with a TV, in mobile AR, which is shown on the bottom left with the microwave oven, in VR with the controller-based interaction, which is shown on the bottom right with the toaster, and in VR with the hand tracking based interaction, which is shown on the top right with the car infotainment system. All devices basically worked as expected. The only thing that we observed was that we had some smaller rendering issues. For example, that some of the videos on the TV were played upside down in some runtime environments. What we also found out is that we need to improve our framework in some aspects. For example, for the car infotainment system, we reached some kind of state space explosion. There were quite many states that we had to cover, and even more transitions between these states, because on a touch screen there were many regions that the users could interact with, and we configured all these regions, and this led to quite many states and transitions. What we also know we need to support our other interaction techniques, and there are even more improvements, but for this I want to refer you to the paper. What we already started working on is a configuration user interface. The reason is that currently all these specifications are done using text files, but in the future we don't want users of our framework to write text files. Instead, we want them to do all these specifications in some kind of what you see is what you get paradigm. And for this, we are currently creating a configuration user interface in which you can load the static 3D model of a virtual prototype. Then you can select different elements of these models. You can specify what type these elements are, for example, whether they are a button or a light. And then you can specify the different situations and states in which a virtual prototype can be, and which interaction actually leads from one state to another. And with this, I come to the conclusion. So what we implemented with the Vivian Framework is a first step towards fast and efficient virtual prototype authoring. Our virtual prototypes can be run in different types of XR, and you can use as input basic and commonly used 3D models of virtual prototypes. You only need to extend them with one specification, and afterwards you can run them and interact with them in different types of XR. And with this, I want to thank you for watching the video. Have a nice day and see you at the conference. Bye bye!